Now in this problem we have been given a radical equation and we have to solve for x. So we have root x plus root x square and this is equals to root x cube plus root x4. And we have to find value of x that satisfies this equation. Now initially it may look that this is a tough problem, but this is a very easy problem if you use the rules of exponent. Now root, that is a square root, is basically nothing but something power 1 by 2. So I can write a square root, so a square root of x can be written as x raised to the power 1 by 2. So let us use this and then we can write x raised to the power 1 by 2 plus x square raised to the power 1 by 2 is equals to x cube raised to the power 1 by 2 plus x4 raised to the power 1 by 2. Now you remember the rule of exponent, that is if you have a raised to the power m and then whole power n, then this can be written as a raised to the power m times n. Now let us use this rule. So what we will have? We will simply multiply the powers. So x raised to the power, here I have 1 into 1 by 2, so simply 1 by 2 plus x square and then we have a square and 1 by 2, that is 2 into 1 by 2. And here I will have x cube, so 3 multiplied by 1 by 2. And finally x4 multiplied by 1 by 2. So this will be x raised to the power 1 by 2 and 2 into 1 by 2 is simply x, and this is x raised to the power 3 by 2 and this is x square. So let us take this term, that is x raised to the power 3 by 2 to the left hand side and x I can take right hand side. So what I will have, if I use this, I will have x raised to the power 1 by 2 minus x raised to the power 3 by 2. And this side we will have x square minus x. Now here I have x raised to the power 1 by 2, here I have x raised to the power 3 by 2. Basically I can take x raised to the power 1 by 2 common. I can write x raised to the power 1 by 2 and x raised to the power 3 by 2 can be written as x raised to the power 1 by 2 times x raised to the power 1 and this is x square minus x. This I am writing because you have the rule of exponent, that is x raised to the power m plus n is equals to x raised to the power m multiplied by x raised to the power n. So in this case you see m plus n is 3 by 2 and m is 1 by 2 and n is 1. So 1 plus 1 by 2 is equals to 3 by 2. So now I can take x raised to the power 1 by 2 common. So I will have 1 minus x. And similarly, if I take x common this side, I will have x minus 1. Now let us take everything to the left hand side. So I will have x raised to the power 1 by 2, 1 minus x, and this will be minus x, x minus 1 is equals to 0. So I will have x raised to the power 1 by 2, 1 minus x, and let us observe the minus sign. So I will have x into 1 minus x is equals to 0. Now 1 minus x is here and this term is also here. So what I can do, I can basically take 1 minus x common. So I will have 1 minus x and then I will have x raised to the power 1 by 2 plus x. And x raised to the power 1 by 2 can again taken be common because I can write 1 minus x, x raised to the power 1 by 2, and this x can be written as x raised to the power 1 by 2 into x raised to the power 1 by 2 and this is equals to 0. This I am writing because I am using this rule that x raised to the power m plus n is equals to x raised to the power m into x raised to the power n. So now what I will have? I will have 1 minus x, and from here I can take x raised to the power 1 by 2 common. So I will have 1 plus x raised to the power 1 by 2. This is equals to 0. So now we have 1 minus x raised to the power 1 by 2 into 1 plus x raised to the power 1 by 2 is equals to 0. And x raised to the power 1 by 2 is nothing but root x. So if you want, you can write root x into 1 minus x, 1 plus root x is equals to 0. So what are the solution I will have? One solution is this is equals to 0, or this is equals to 0, or this is equals to 0. So root x is equals to 0. This means x is equals to 0. 1 minus x is equals to 0. This means x is equals to 1. And 1 plus root x is equals to 0. This means root x is equals to minus 1. And this means if you square, then this is x is equals to 1. So we can have two possible solutions. One is x is equals to 0. Another is x is equals to 1. So we have in this case two possible solutions. X is equals to 0 and x is equals to 1. So it is always a good idea to verify whether this satisfies the original equation or not. So let us check whether this satisfies the original equation or not. So you have original equation x plus x square and then a square root of x cube plus a square root of x4. So 0 will obviously satisfy. This is 0 plus 0 is equals to 0 plus 0. So 0 is a root because this satisfies. What about 1? So we will have root 1 plus root 1, 1 square is 1, and then again root 1, and this is again root 1. So this is 2 is equals to 2. So basically both roots satisfy. This means x equals to 0 and x is equals to 1 is indeed a solution of this equation. So I hope you enjoyed this video, and if you enjoy, please share with your friends, like to this video and subscribe to my channel. I will see you in the next video. Thank you.